Here I'm going to talk about the exploration of dimensions, why Einstein extended from 3D to 4D, and his hint at an extra fifth dimension. This is an external macro dimension, not the micro 10D of string theory. The extra dimension may have profound impact on particles and gravitation and offer answers to such mysteries as quantum gravity and dark matter. History of dimensions. 0D, a point, not many features. 1D, a line, not many features. 2D, Pythagorean theorem, found 2,500 years ago. 3D, man has known it since the beginning of time. 4D, Einstein found it in special relativity a century ago. 5D, special relativity hinted at it. A rigorous definition of Lorentz spacetime actually leads to 5D. Why 3D to 4D? Special relativity. The law under 3D Newtonian mechanics is, if a car is moving at velocity vc on the ground, a person on a ship moving at vs will measure the car at velocity v total equals vc minus vs. But this rule is not followed by light. If a light ray is emitted on the ground with velocity c, a person on the moving ship will measure the light also at c, not at c minus vs. To make sense of this strange phenomenon, special relativity suggests that every uniformly moving frame has its own space-time scales, which should be so defined that it measures all light at the same speed regardless of its frame velocity. That is, with some derivation, we obtain the Lorentz transformation between two space-time definitions of frames moving to each other at velocity v in x direction. Notice that in Newtonian mechanics, all uniform frames share the same 3D space. But now time is added, and a separate 4D Lorentz spacetime exists for each frame. 1.1 is a 4D Pythagorean theorem. Just like a rotation in 3D space, Lorentz transformation is a rotation of an imaginary angle between x and t axes, which amounts to distance contraction and time dilation. If your apparatus were super accurate, you would experience this kind of 4D rotation every day. As light is an electromagnetic phenomenon, Lorentz spacetime is essentially defined based on electromagnetism and was discovered by Lorentz. When expressed in Lorentz spacetime, electromagnetism appears most elegantly. Einstein's idea is that Lorentz spacetime is for mechanics as well, which yields a universal four-momentum identity. The length of the four-vector rest mass remains constant no matter how the four spacetime is rotated. When the object is static, the equation reduces to E equals mc squared. When a bottle of water is heated, or when the electrons in an atom are excited, its energy is higher and its rest mass is higher as well. According to Lorentz spacetime definition, anything faster than light arrives before it departs. Thus, the theory forbids anything faster than light. It's a great theory, but is it the end of dimensional exploration? I don't believe so. Why? I'll answer this question and more in Part 2.